Since I'm also the host of this track, nobody will announce me. I'm Maurits van der Schee, product owner for LeaseWeb, responsible for the website and the customer portal. Today I'm going to talk to you about web applications, specifically about session management, which is one topic within building web applications. We're going to talk about session management when you have more than, let's say, your corporate blog, or not your corporate blog, your homepage or your private blog with a little amount of traffic which runs on one VM. So as soon as you start scaling it to multiple machines, you may run into problems. And now, well, I'm going in depth on this topic. Also, we're a proud member of the MCM PHP community. We hosted a meetup last year. Please look it up if you don't know it yet. HTTP is a stateless protocol. Well, maybe this is all known to you guys, and this is very basic, but I start with the basics to go into depth very fast. It means that every request you do to the web server is unrelated to the previous request. So the web server doesn't know anything about you when you do the next request, about your previous request. So, well, this is what normally would happen if you would request a login page. You would request the login page. It would give you back the login form. Second step would be that you submit a username and a password. Then it checks its server side and says, "Oh, that's correct." And it says, "Okay," and I'll redirect you to another page, which is the secure page. And you request the secure page, and it says, "Well, who are you?" Right? Doesn't know, because it doesn't know. It just validated you as a legitimate user. So, well, you have to find a way around that. Of course, you could send the username and password on every request, but wouldn't make sense. Well, we thought of, the internet thought of something called sessions, and these are typically made with a random number that's added to every request, and that you have to pass back and forth. So, of course, this is the basics, and to people into web development, they'll all know this is how the internet works. This is done with cookies. It could have also been done, and it's actually supported, to send it as a get parameter, which is what you see on method 1, but it would make your URLs very ugly. And also, when you look at real-life applications, nobody's doing this. It can be done, but it's not used. So the method that everybody uses is to send cookies. You see the two cookie headers displayed. The first one is the response header. It tells your browser to store a cookie, and then on every next request, this cookie is sent with the cookie header, the bottom line, sent back to the web server saying, "Yeah, remember I was this user with this identifier. I just logged in. You can trust me." So we need cookies, right? But cookies have a bad reputation, right? Everybody says we shouldn't have cookies, cookies are bad, but cookies are not bad. I mean, certainly not all cookies are bad. If cookies were all bad, then you wouldn't be using any application on the internet, because every internet application that you have to log into uses cookies. But it uses a specific type of cookie. It uses the first party. It's a first party cookie because it's served from the same domain, and it's a session cookie. It means that when you close the browser, it's discarded. So there's no risk of tracking or privacy leaks or any of that. So it's a good cookie, right? So remember that. But where do you store the data about this session, right? Well, there's several options. You can store the data about the session on disk, which is the default in a PHP web application. It will store it on disk. You can also store it on a relational database, a SQL database, like Drupal does. I believe there's other systems that do this. Or you could use a key value store or a NoSQL database to store your session data in, like Memcache or Redis, or various others. Well, in PHP specifically, you could write your own session storage mechanism by using the session set save handler, as you see in the bottom line. I do not recommend that you do it unless you really know what you're doing, because it's not so trivial. I'll show that in the next slide. But okay, so let's compare these types of storage. On the left, you see a simple way of storing session data. You do it on a disk. It's on the local machine, and it's on a central place. But as soon as you get multiple web servers, you are looking for more. You need a more complicated way. You could choose, for instance, on the other end of the spectrum, you could choose memcache on a remote server and shard your session keys over multiple servers, so that each of the memcache servers holds a partition of your sessions. So, of course, you could mix and match a little bit to get semi-complicated setups. But as soon as you have multiple web servers, you will have to do something more difficult than the simple method that is configured by default. Of course, then which one would perform better? And then people would say, well, if it's stored in memory, it must be faster, right? On disk, it can be fast because it has to do I/O and all that kind of stuff. But in reality, that's not true, because in reality, your disk actually has a LRU cache. Your file system has an LRU cache, and it will actually work very good, and it will not do any I/O on your session storage. So in reality, the LRU cache of memcache is similar to the LRU cache of your file system. So the performance will be just as good, minus the network overhead. So in reality, this simple system is also the fastest. But yeah, it doesn't scale. So your web form will not benefit. How do you configure? Well, by default, the configuration of your in PHP of your session storage is as shown, with files in a directory where your files are stored. In that directory, you'll see file names containing the session identifier, and then in that file, you will find all the contents of the session data in a deserialized way. Sorry, in a serialized way, of course. Memcache does the same, but it does it on a memcache key value store. So the keys will be the session identifier again, and you have to configure that you can reach this memcache over the network. And of course, this is the simple configuration. You can also add multiple servers and tell it how to shard and all kind of options which are left out. And you can find that in the manual. I would recommend that. But why shouldn't you use SQL database for storing your session data? Well, one of the reasons is for performance, because database systems are built to be asset compliant. The writes are not cached. Well, that means that if the power would be shut off of a database server and you just did an insert, you want the insert to be there, or the update to be on disk, right? So that's what the database system is built for. So it doesn't use your file system cache, so the writes are cached. Of course, you can turn it off, but if you use the database system also for other things, you might not want to turn it off, so then you would have to run a separate database server to store your sessions in. That's, of course, possible. So that's the first thing. The second thing is locking in database is quite expensive. Why you need locking, we'll get to that in a minute, but locking in database is expensive. In MySQL 4, for instance, you could do a full table lock. Well, that's not really a database, maybe. So, but in MySQL 5, you have row locks, but they're still quite expensive. Then I looked, for instance, at Drupal, which is a technology we use. And I saw that we were using MySQL, and it doesn't lock. I was like, what's going on? Why doesn't it lock, and what impact could it have? So the theory is that the modification of your session data can get lost without locking, and I'm going to explain that. So locks are useful. This is our data center. Locks are definitely useful, but not that kind of locks. So locking and releasing. First, I'm going to explain the page load and when lock should be set and when it should be should be released. So when your page is loaded, automatically or not automatically, it will call session start, depends on your configuration, and it will look at your cookie, find the identifier, find the file on disk or in memcache, deserializes the contents, put it in a session variable, and then your script gets executed. Your script has access to the $_session variable and can modify it, read it, write it. And then when the PHP script is done, it calls session write close, serializes the contents of the session variable back to the disk, and releases the lock. The lock on the disk is the flock system. The flock is the advisory lock system of the file system. That's used by default, and that works very well. If you don't call session write close, well, PHP will call it automatically, so you don't have to worry. If you program PHP and you never call this function, that's perfectly normal. So let's go a little deeper and look at a scenario. On the left, you see a case where there is a 0 in the session variable stored. Let's read it, increment it, and then write a 1 back into the session variable, and then do the next request. Let's say that that request was going concurrent, right? Well, if there's a locking system, it will wait for the write of the 1 to be done, then the next request will read the 1, and then we'll increment it and write the 2. And if there was a third concurrent request, the same will happen, right? And the end result will be 3. If you don't have locking, well, on the other hand, you see that on the right side, you'll read the 0. Concurrent request comes in, also reads a 0. Both increment, both write a 1. Well, luckily for the third request, the 1 was written, it will increment and write a 2. So the end result is different. May not seem important unless you have a shopping cart, of course, with products in there and people buying stuff. That might be a little bit more important than suddenly. So I wrote a script, and I'll make this available on the web so you can run it yourself as well. What the script does is I'm going to try to explain it fast. It calls session start, and if this is the first request, it will initialize the session C variable with 0. If it's not the first request, and this is an HX request, then it will increment the session variable with 1, sleep for 1 second to make the effect more dramatic, and then die. Okay, if this is the first request, then the script will be executed, because it didn't die, and it will do 25 requests to the same page, using jQuery for brevity. I executed this on memcache, and although this seems a bit messy, this is exactly what it should do. So you see a get request going on, gets the page, gets jQuery because it's a dependency, then does 25 post requests, and the first one I clicked open, you clicked on the little plus, and you see that the response was 1. Well, that was expected because we had a 0 there, and it became a 1. Then on the second request, well, the second request you think might be the second one in a row, but it wasn't, because this was pipelined with 6 requests. So these other 5 requests had to be waiting until the other requests were done. So believe me, the second request was the one underneath the one with 25.29, so the one with the short bar at 1.97 seconds, so almost 2 seconds. That should have been then, of course, the 2, 3, 4, 5, and then when you get to this 5th request, you see I clicked it open again, you see it's a 5, right? And then on the 9th one, it's a 9, and when the thing was almost finished, well, then the pipeline, the other request got executed, and you see a 21. But you see that also in the timing. I could have made this pretty, but this is not the reality, so this was the reality. When you use Redis, for instance, the native handler from PHP, this happens. Well, so yes, this goes much faster, right? But it's not completely right, because if you open up the one of the, for instance, the 7th request, it will show 2. And I think on the 14th request, it will do something. That's maybe not the 14th, but a number 3. So it happened what we just saw on the schema, that actually happens, right? And we see it here in reality. And you can run it at home with the script. You can see it. So this locking might be important. But why then, for instance, if you use symphonies from the official Symfony distribution, the Memcache session handler, why does it do a get and a set? And why doesn't it lock, right? So I don't understand that. I don't understand how that error could have got in. So, but it's not only Symfony, because Laravel did the same thing. I guess they copied them or so. I don't know. So there is one implementation that does this correctly. This is the SNC Redis bundle. But, well, I was the one contributing this code, so maybe that was the reason that it's got in there. So, and I can show you that this calls lock before read. So this sets a lock before reading. That's what the highlighted command does. We can dive into that, and you can see I use two Redis commands. It's a spin lock, so it will try to acquire the lock, and it will use the set if not exist, which is the set nx command. So set if not exist, and if that succeeds, then you have acquired the lock. And this is a function made by Redis on purpose to do this kind of locking mechanisms. Of course, I add an expire afterwards. So if you don't release the lock within time, which is the PHP max execution time, well then we release the lock anyway. So implementations that do lock. Well, the default implementation, so don't worry if you run your personal blog or a small website, it's fine. Both the Memcache extensions that are available in most repository, which is the PHP 5 Memcache and PHP 5 Memcache D extensions on Debian-based systems. Well, this SNC Redis bundle, well, we also have made a bundle based on Memcache. It also does it in PHP. Actually, I copied the code and I submitted it to Henrik. And those are the things that do it correctly. And all the other implementations that I know of are not doing this. So, well, lessons and conclusion, I guess. Well, you shouldn't blindly trust your session storage implementation, although you would think that you could. And now some actual tips. I mean, let's say that you have a good locking system. I have heard a complaint like, I don't want locking because it hurts my performance. Well, that might be true, but it hurts your performance for a good reason. But to make the pain a little less, you could call this session write close earlier in your PHP application. So as soon as you're done writing to the session, you have nothing to write to the session anymore, you could immediately call session write close and your lock will be released. So let's say, for instance, you're sending a lot of JSON output to the client. If you don't explicitly call session write close, the session log will only be removed after the output is sent to and accepted by the client. So you could call it before sending the output, and that would actually help a lot with the lock and just the concurrency of your application. And my proposal is also to add a new PHP function, which is session read only, which is an alternative for session start, which will do the same as session start, but it will just not add a log. And that means that it will also not do the session write close, or it would give an error message if you would try, because that would mean that you can only read the session data and not write it. Well, for instance, if you have a JSON API that does a lot of JSON data, well, you typically only want to know, is this customer logged in? Can I expose the data to him, yes or no? And if you can, well, you don't have to actually do anything with the session other than reading that he's logged in. So in that case, session read only would do. So I made a bug. Well, I didn't actually. Somebody found this bug report, which actually asks for exactly the same thing. So that's 8978. I didn't even find it. Somebody commented that on my blog post. And so I would all ask you to thumb up this bug, of course, 8978 on php.net. And maybe we get this and we can make the web a little faster. That's it, I guess. Any questions?
Thank you. So if I understand it right, you are storing the data in the Memcache and you are locking it via Redis. Where do you store the data otherwise?
Okay, so that's I was showing you several implementations, and one of them was Memcache, and one of them was Redis. So Redis is a way of Redis by default in the native driver doesn't lock the session data. Memcache in the native driver does lock the session data. So I think that was a bit of the confusion. So I think that invalidates the question, I guess. But so I propose that you either use the native driver from Memcache because it does proper locking, or if you use Redis, you should use, for instance, SNC Redis bundle if you use Symfony, because that actually adds locks to the session management.
Yeah, but you cannot just store data to Memcache. You have to store it also somewhere else. It's not persistent.
Okay, so about persistency, yeah. So there's if Memcache crashes or you reboot the server where Memcache runs, then you will lose your data, right? That's your concern. Well, that's true, of course. So if you would choose, for instance, a Memcache as a session manager, you would not want to reboot the server because then all your users would be logged out, right? At that moment, if you store the session data there. If you use Redis, you can actually configure it to also be disk backed, or so that would be an advantage of using Redis over Memcache.
But it's not just rebooting; it can also like roll over the memory of what is allocated to Memcache, and then Memcache starts discarding all the sessions.
Yes, this is also a valid concern. So if you don't allow enough memory for Memcache to be there, then Memcache will automatically evict the least recently used data, which could be a session that somebody is still using. And in that case, well, people are logged out, and you don't want that. So what I would recommend is that you actually set the proper expire headers, and that you monitor your memory usage of Memcache, or the amount of slabs that you have in there. But you can also rely on, for instance, I think Redis is a little bit more complicated, more sophisticated. So if you need that sophistication, then you could choose that.
Yeah, there's a double write option. There's a double write option in the native Memcache handler, so you can have failover when you reboot the server.
Yes. Okay. So yeah, indeed, you can have the cluster either the Memcache cluster either shard or double write, or both, I believe. So you can make more complex setups with Memcache than just one single server, and that could help you indeed. But it still doesn't cover the that you still have to monitor the memory usage of your Memcache servers to avoid running out of memory. Yeah. Can you pass on the mic?
Probably, as you know, that's impossible to synchronize Memcache on the server, on the server level. So, as usual, we can synchronize Memcache, for example, sessions, using the library. Well, as far as I know, it works in this way. So, we can synchronize Memcache with on the Memcache side. We should do it as usual. For example, Memcached library for PHP, just manage it on the library level, right? So what the question I have, how it, how we can lock it on multiple Memcache instances? It's the first question. And the second question, do we have really a lot of overhead when we have more than one Memcache server?
Okay, let me try to recall your question. So the first one was, can you synchronize, can you have the logs on both servers where you have the double write? So the double write will also write the logs twice. So I guess that's the easy answer. There's no such thing as a log, but if you look into the bundle, you'll find the actual commands to do atomic increments. I think it's check and set that is used on Memcache as an atomic operation to implement the log, but it's sent to both servers, so you don't have to worry about that. And the other thing was, remind me. Oh, the performance. Well, if you use a double write, well, all things will be written twice, right? If you have a busy internal network and you're going to run a lot of Memcache servers, well, the busy network may actually degrade your Memcache performance. So then the more servers you have on there, well, the more it may degrade. But so yeah, it would degrade linearly, I guess, by adding servers. So I would be careful with adding too much servers, make the setup too complex. But in most cases, that is, I guess, acceptable. I don't know, for your setup, you would have to calculate that, I guess. It's almost, I think it's time. It's been 12 o'clock. So I think the next thing on the schedule is the coffee break, right? Lunch. Okay, the lunch. So thank you all for attending this, and